Stanford University.
Okay, well, welcome to lecture number 3 of CS193P for fall of 2013-14. Today I'm going to jump right into a demo, and then after that I have some slides, time permitting, assuming the demo doesn't take the whole time here. And the demo I'm going to do is I'm going to take the little card thing we did last week and turn it into a real card matching game where we're actually matching cards, okay, rather than just flipping them over. And like I say, if I have the time, I'll talk a little bit more about Objective-C, and we're really going to go into Objective-C on Wednesday in quite a bit of detail. I also included on the stuff I posted some review slides at the end, just kind of reviewing what we will have learned in the first 3 lectures, just so you can kind of look through it real quick and say, oh yeah, do I know that? Yeah, I do. And if not, then you can obviously post and ask us questions about it. Okay, so let's do this demo. So for the demo, I'm going to start this demo actually by giving you the solution to the homework. I told you I was going to do this. This is the only time that I'm going to do this quarter. Normally I don't go over the solution, but the solution is so simple, and because obviously we need the solution of this to move on to what I'm going to do today, we'll do the solution first. So here I'm just launching Xcode. You can see now in my recents I have this machismo from last time. So we'll bring that up. There it is. Make sure that we're using as much screen real estate as we can here. Some of these wires out of my way. Okay. So if you remember where we left off, hopefully you remember because you did your homework. We just have this single card, and it flips back and forth between the ace of the clubs. And your homework was to use the model that we worked on in lecture to make it flip through an entire deck. So the solution to that is quite straightforward. We obviously need a deck, so I'm just going to add a property here. Strong property, should be strong because we need that deck to stay around. And it's going to be a deck, and I'm going to call it deck. Okay, now we have an error here because of deck, so we have to go up here and import deck, right, to make that error go away. So now we got this property. That's cool. Obviously, we want to use lazy instantiation to instantiate that property, so I'm going to do that. That's a deck scar deck. And I'm just going to see if my instance variable is null, or nil rather, 0 basically. Then I'm going to say, underbar deck equals, and I'm actually going to create deck using another method here. You'll see why in a second. And then I'm going to return underbar deck. Okay, and create deck is just going to create a deck. Create deck, and I'm going to create a playing card deck because that's what you were asked to do. So I'm just going to do alloc init to do that. I got an error here because not only do I need to import deck, but playing card deck. And it's actually kind of unfortunate here that in this nice generic card game that I'm building, that I'm importing playing card deck. Why is that unfortunate? Well, I'm going to try and build a card game here that has nothing to do with playing cards. Okay, it's going to be a generic, should work with any kind of deck. Okay, a deck of any kind of cards. And in fact, in your homework, you're going to be asked to enhance the game next week to play a different deck. Okay, so it's unfortunate that I have to do this, and in lecture, either on Wednesday, probably on Monday, we will talk about how we can get rid of this. Okay, get this import playing card deck and this create deck method to be more generic, okay, and not be so specific to playing cards. But anyway, so now I have this deck, and it's lazily instantiated. So now that I have a deck, I can use it to get rid of this little ace of clubs thing right here. Okay? And I'm going to do that by saying here card star card equals self.deck draw random card. So I'm going to draw a random card out of the deck, and then instead of putting ace of clubs here, I'm going to put the card's contents. Okay? And that's really your entire homework assignment. There's one other minor thing that I'm going to do here, actually 2 minor things, because we don't want just a solution that works. This will work if we run this you're going to see it works, but it's kind of not very elegant, it's not really a really very good solution to the problem, even though it functions. You see, it's going through the random cards here. But it was kind of annoying, a couple of things. One, it started out with the ace of clubs. That was kind of gross, okay, because if I keep clicking here, eventually I'm going to get the ace of clubs, there it was, back again. So that's kind of bad. The other thing is when this deck is empty, this is not going to particularly elegantly finish off, and we want to have some elegant solution, and I said in the hints come up with an elegant solution. Also this flips thing here, once I flip through the whole deck, it's going to keep flipping. It's going to go 102, 103, 104, 105. That's not very elegant either. So let's fix all three of those things with simple elegant solutions, okay? So my simple elegant solution to the ace of clubs, which I hinted at for you, is simply to start it face down. So I'm going to get a card back here, get rid of the ace of clubs, and now this card starts out face down. So I didn't even have to write any code, and I just used my brain over my brawn to make sure that this works, right? So that's kind of an elegant way of thinking about solving that problem. So we'll just start it face down. There was no required task that said you had to start with the ace of clubs face up. So that's a good solution. When it comes to running out of cards, I think an elegant solution is it just will stop flipping at that point. I mean, you could make arguments, load up another deck, other stuff, but I think a simple solution is just once you run out of cards, you keep clicking and it stops flipping, okay? So how are we going to do that? Well, I know some of you are going to say something like, if number of flips equals 102, then stop flipping, and that's really, really bad, okay? That's very bad design, because that 102 is like a magic number you've just put into your program, and there's completely no reason for that bad design either. All you need to do is just say if card, then flip it. Okay, so I'm going to flip it here. I'll make some more space so you can see. Otherwise, I'm not going to flip it. Okay, so this is a super elegant solution to, not continuing to flip this thing over when the deck runs out. And we know that draw a random card returns nil. If you remember from our implementation, it returns nil when the deck is empty, so perfect. Once it's nil, it's just not going to flip back over to the content size. It's going to always stay on the back side. Question? So then what about flip count? And flip count is the third thing that was kind of not very elegant. So how can we fix that? Well, there's a number of ways to go at that, but I think a simple way is to only flip, when we actually do the flipping over. Now, this is kind of not a great solution because here we're not actually flipping over. If we're on the card back, then we're flipping over here. So this one's kind of not so good because we're kind of going to, once we flip over to the back, we'll be okay because we're going to be starting to do, we'll be executing this code over and over right here because we'll always be on the back. So I think this will work, right? Is that a good solution? The reason I don't like it is I don't like having this line of code in two different places. Kind of eh. I could have done a lot of other things here. We could have factored out the image and the string into separate local variables and had our if, apply those and stuff like that. I think all of that would be a little bit of overkill. So let's see if this works. So here's our thing here. So it started face down. Let's click through the deck here. I'll click through it quickly. So I'm clicking so quickly through this, you'll notice that I'm not giving time for the thing to finish animating. Okay, and we're going to start talking about animation in the week after next. And one thing about animation is it's going to happen a little bit out of band with what's actually happening. So I am actually flipping here, and all that flipping is happening, but the animation is kind of slow, and it's staying behind. And that's kind of just, unfortunately, the way it is. The animation will eventually catch up. But here we go to our last card, and we get face down, and now we click, and it's not flipping over, and it stopped at 104. Okay? Any questions about this solution? Pretty straightforward. Again, elegance, simplicity, that's what you're shooting for in your homework, okay? Big overwrought solutions where you're adding a bunch of API and checking a lot of things are generally not preferred over more simple solutions like this, even if you have something where you kind of have these two lines of code that are doing the same thing, maybe shouldn't be replicated like this. It's a close call as to the really perfect elegance, but I was going for simplicity here too because I only have so much time. Okay. All right. So now we're going to go into doing the next phase of our card matching game, which is to make the game actually play. Now, the playing of the game is part of our model. It's really important to understand it's not part of our controller, it's part of our model. Because I told you that the model is the what your game is. Well, what is this? It's a card matching game, so the what better be in the model. So we're going to create a class in our model that is going to encapsulate the logic of the game playing, and it's not going to know anything about user interface. Okay? It's not going to have any things in it that have anything to do with user interface, and that's a really important distinction to make. So let's create that new class. Remember that we always create new classes, same way you did with your assignment today, by saying new file. Okay? And we want an Objective-C class, and I'm going to call it card matching game. Okay? And it's going to inherit from NSObject, as all of our kind of base classes do. And I'm going to put this thing in the same directory as the rest of my model, and I'm also going to put it in the same group in the navigator as my model as well. Okay, so it goes with all these guys, and it goes in this group. That's a nice thing to remember to do. All right, so we create it. Here it is. Okay, here's its header file right here, and I'm going to use this counterparts, automatic counterparts, to show the implementation. Okay, so there is its header file and its implementation. And when I design a new class, I always try to give my first crack at its public API first. Okay, I'll go do its implementation later, but I want to kind of think of how are people going to use my class first, just to drive my overall design. Okay, and that's for a simple class like this. If you got a more complicated class, you might be having significant design meetings with your team to understand what's this object, how does it fit into the world. But if you're just doing a simple, straightforward class, especially if you're doing its first iteration, it's sometimes nice to just think, what is its API, we call it. Okay, API is the public programming interface for a class. So I need to think of what this card matching game needs to do. Well, one thing I know it needs is an initializer, okay, an init. But when I think about my card matching game, there's a couple of things it just has to know to initialize. It can't just initialize itself like a playing card deck can. A playing card deck knows everything it needs to know about a playing card deck when it's started, but this doesn't really know that. So I need a couple of things. One thing I need is, how many cards are we playing with? Okay, how many cards is the person allowed to match total, right? What's the total amount of cards? So we need that. So I'm going to say init with card count, and we'll make an NSU integer. Really, that count has got to be at least 2, you would think. So I probably, in my initializer, should check to make sure it's greater than 1. And if it's not, I'll probably return nil from self. In other words, I won't initialize. My alloc init will return nil. Okay, and we'll pick one way where it does return nil, but we should probably check that too. The second thing that I need is a deck.